Okay, so hello everyone. My name is Zainab, and I'm going to conclude the session with a communication paper, which is entitled Towards a Granular Computing Framework for Multiple Aspect Trajectory Representation and Privacy Preservation. So the main aim here is to talk about some research challenges and opportunities, and to present this introduction of granular computation theories like posisets, soft sets. How can we use them for multiple aspect trajectories? So, okay. So this is the outline. I'm going to introduce the context of this work, and then the motivation, and then multiple aspect trajectory. What are they? And then the potential of using a granular computing framework to multiple trajectory representation, then challenges and the opportunities. So as you know, today we are living in this era that we have large amounts of data which are collected from different smartphones, various connected sensors, the wearable devices. And these data include positioning and trajectories reflecting our mobility, so the user's mobility. But this movement data can be still enriched with other aspects, other dimensions, which are the semantic dimensions. So this is a very simple example of a semantic trajectory. So you can see here it's very rich in terms of semantics. So we can here have the different information tied to the weather forecast, for instance, our emotion at a specific time, at a specific place, the means of transportation that we have, how we vote, for instance, a restaurant, etc., etc. So we have several aspects that enrich the trajectory, the semantic trajectory. And this semantic trajectory can be represented with respect to different dimensions, which mean that I can take the same semantic trajectory and represent it in terms of transformation means only, or another aspect in terms of weather forecasts, for instance, or emotions, etc. So the fact of representing differently using different aspects or different dimensions, this semantic trajectory leads us to the terminology of multiple aspect trajectory. So it is evident and obvious that these individual semantic trajectories pose several privacy issues because it highlights several sensitive information. We can know the surrounding environment of the person, we can know their habits, we can know what they are doing at a specific time and place, and this, of course, all violate the user's privacy. So we believe that there is a need of another structure that permits the representation of multiple aspect trajectories while considering a privacy preservation. And in this communication paper, we just want to introduce the perspectives of applying granular computing formal settings like we can apply website theory, fuzzy website theory, and any hybrid theories proposed or introduced by Professor Chris during our first tutorial in the emphasis. This is, of course, to represent multiple aspect trajectories. So we introduce a framework that we call GRC-MAT, and we will see if we can use this framework to also consider this privacy preservation aspect. So very quickly, what is this multiple trajectory representation? So this is an example of three trajectories that we call P, Q, and R. So here we have different aspects. This is just the word trajectory. Then we have the aspect which is stops and moves. So we can have here different stops which are home, university, shopping, cinema, gym, restaurant. The other one is the transportation means. So we have here food by bus, and then so on food by bus. Yeah, I think that's it. And the other one is the weather condition. So we have rainy, sunny, and cloudy. Okay. So now if I'm going to do kind of a reasoning or mining, I'll say, so if aspect equals row trajectory, then I'll check the similarity relation between the trajectories, and I'll say, okay, based on this, then P and Q are the closest. If I'm going to consider the second one, if aspect equals stops and moves, then based on the labels that I have here, home, university, and shopping, for both P and Q, they are the closest. Same for transportation means as an example, and then for weather condition, I'll see here rainy for Q and R. So based on the user similarity relation and the label that I suppose for the different trajectories, Q and R are the closest. But still, the problem is that when we have to use such similarity analysis, the what we have in the literature, we only have similarity analysis, which is based on single aspects of a single dimension. I cannot take all the aspects together in a single representation. And in real world, we do not deal with different aspects or dimensions of trajectories like separated, but we have a combined representation. We should have a combined representation. So the question is, okay, what's the problem? I mean, why don't we just get all this data, this information in a single representation and just represent this multiple aspect trajectory, this MAT? Well, it is not straightforward. Why is it not straightforward? Because if I'm going to take an example here, assume that we have a moving individual who's just moving, walking, and then the weather changes from sunny to rainy during a single stop. The activity aspect, the moving individual changes his or her activity from meeting to coaching when the weather was raining, and then the weather changes again to sunny for a specific slot of time, etc. So you see here they have this dynamic or evolvable nature of the multiple aspect trajectories, and this is with respect to nature actually. So it is difficult to combine all these information in a single representation, and this is why we need a new way or a novel way, just another way to represent that. So with respect to this example, so how can we correctly split and annotate the stops into different weather conditions with respect to different time slots? How can we divide the different activities? How can we represent all this information in a single representation and use adequate similarity relations? And how can we, of course, perform mining on this? And in this direction, we thought about why not introducing granular computation to multiple trajectory representation. So in the paper, in the communication paper, so I have defined all these definitions, but I'm not going through this, so you can just read them in the paper, please. And I'm just going to go to the practical use case as we are running out of time. Here, for instance, this is the framework that we currently propose. So you have here the different dimensions: space, temporal, weather, transportation, activity, etc. And then we have represented it in structure of a tree or a network or graph. So you can imagine this whatever structure that you can use, which is composed of different layers. So each layer can represent a data granule, and then the sublayer after that, the second layer will be composed of subgranules of the layer above, etc., etc. And then the connection or the relations or the similarity between the different granules can be represent these edges that you see between the different layers or between the granules or the subgranules. So adopting already such a structure can represent this dynamic framework or architecture that we are looking for, because you can add different layers, you can add different granules, you can split a granular form to subgranules, or you can create number of granules, you can merge, etc., etc. So you can play around the architecture with respect to this evolvable or dynamic aspect. So if I'm going to be concrete, this is a very small example. I will have the first box where I have the different aspects, so 4 aspects: space, temporal, weather, activity. The first layer is representing the global granules, which are a single aspect, and then the second layer divide the first granule into further subgranules. So for instance, weather, I will have sunny and rainy. Temporal, I have the start minute and end minute. And the space, the most important one, I have the label, which is the POI. So if I'm going to do, and of course here you have the edges, different relations between the data granules. So here, in terms of reasoning, I can say, okay, so at PY, weather equals, for instance, sunny, at temporal, starting minute equals X, and end minute equals Y. So I have this time slot, and activity equals food. So I can consider all the granules within a single representation. And same, if I will say, so at PY, the same label, weather equals raining at a different time slot with activity equals food. So with respect to the need of representing different aspects at a time, different subgranular structures can be extracted from such MAT representations. So now in terms of reasoning, weather represent, as I said, an aspect which represent a data granule. Sunny and rainy are subgranules of this second layer, which are subgranules of the first layer or the layer above. and so on and so forth. So you can play around this. And then I can also represent the subgranules, sunny and rainy, in terms of information system, where they can have, for instance, binary values, 0 or 1, with respect to the other granules. So they'll say, for instance, at start minute equals X and end minute equals Y, sunny equals 1, rainy equals 0, or vice versa. Or, of course, it happens also that we have sunny and rainy at the same time. And you can, construct your data, your information system to be concrete with respect to this kind of relations, and also generate new reasoning granules in terms of considering rough set theory, for instance. You can generate positive regions, negative regions, boundary regions, etc., etc. So you can perform kind of a reasoning based on such structure. And again here, concerning this edge, which represent the connection between the different granules, then these can be interpreted, for instance, as a dependency degree, attribute relation, similarity, tolerance, neighborhood relation. So it depends what structure we are going to adopt. And all of this together will represent, or is able to represent, this mat for representation. So very quickly, I'm going to the research, which I'll conclude with the research challenges and opportunities. So with this mobility data, we cannot talk about uncertainty and imprecision. So let's take an example. If you have, for instance, a tourist group, so they are visiting a city, a specific place, a theater, for instance, and then they have mentioned their location twice in an hour. But then when you are using your app and it's about slacking, then you have to choose randomly one location. And then there is an accident around that location. So if you are not aware of that uncertainty and imprecision that is involved already or invoked in that real environment, then you can think that an individual, a tourist among that group, can be involved in the accident. So you can make wrong deductions. But if you use not rough set theory, but any theory is like about uncertain reasoning, then we can inject how to handle such uncertainty aspects within the model, and we can offer an opportunity to deal with uncertainty and imprecision within mobility data. And then another challenge is, okay, I have presented now a framework based on different layers, but there's still the question, how can I build such structure? And here it's in relation with the database, with the indexation. So it's another field of database, but still, how can I define such granules? How can I define such connection between the granules? How can I build this architecture in an optimized way? Another challenge is how to define the similarity between the different granules. And here, as I proposed earlier, we can maybe think about, with respect to your information system that you're going to extract from some such representation, you can, for instance, think about tolerance, neighborhood, similarity relations. So it depends, but these still can help in formalizing your indexations maybe within the database, or see how you can reason about this. And last but not least, you can also talk about the privacy preservation challenge. If I take still the same structure of this GRC model, then you can, for instance, ensure or favorize the generalizability and avoid specificity from one layer to another, or from switching granules when you report the final results. Or if you want, you can report the boundary region instead of the positive region or the negative region, which can include certain items or certain reasoning aspects. So still, GRC theories, they can still offer this uncertainty aspect, and you can inject this in the final results in order to make some privacy preservation mechanisms, build some privacy preservation mechanisms. So that was it for this communication paper. So we believe that we have presented a novel addition based on granular computation to this mobility data management and the mobility data mining communities. And there are several perspectives that can be done in hybridizing these two domains. So thank you very much. I have also copy pasted my email in the chat. So please do not hesitate to contact me if you are interested in this. And I'm going to leave the floor to Piotr to conclude and to conclude our session. Thank you very much.
Thank you very much, Zaineb.